Hello, my name is Bryce McCourt. I am a student at Grand Canyon University. I am majoring in chemistry education. I am a student in the concepts of inorganic chemistry class, and this is my final presentation of the element yttrium. So first, students would need to be responsible for their learning, and they would need to understand that they need to check their learning. So these are the student learning objectives to help them do that. So first, students will understand the occurrence and the extraction of the element yttrium. Second, students will analyze the bonding characteristics along with the physical and chemical properties of yttrium. Third, students will evaluate the major applicable uses of yttrium and how the element is analyzed using plasma mass spectrometry. Fourth, students will analyze the fate of yttrium in the environment and any effects that it would have on humans and ecosystems in regards to toxicology. And finally, students will understand various teaching and research strategies and topics in an AP chemistry class in regards to learning about a specific element on the periodic table of the elements, specifically in this case, yttrium. Next, the importance of learning a concept would be to understand how an element on the periodic table of the elements is actually important to a real-world scenario in real-world situations. Because really, you don't really hear about this element yttrium in particular. That is why I was interested in studying it, because it's really one of those on the D block that you don't necessarily hear about in a general chemistry class. And so the importance of this element is that it is a unique element and is actually classified as a rare earth element. It has a unique bonding characteristics because it has the multiple oxidation states. Again, it is located in that D block of the periodic table of the elements. And also, it has many applicable uses, such as the following. It was used to produce the first colored televisions. It can be utilized as a catalyst. It can be used to create stronger alloys and used in cancer treatments. Next, there are applicable methods to introduce this content, specifically if your classroom audience is an AP chemistry class. And these could be the following methods to introduce this topic. So first, the instructor could go about with this topic with a combination of direct instruction, and then as the instructor is giving about the knowledge and being the main lecturer and introducing the topic of this, then the instructor could slowly give the responsibility of the learning to the students, make it more student-centered instead of teacher-centered. And then the students could go about being responsible for their learning, and they could do this by such as organizing their thoughts with graphic organizers, such as concept maps or anything such as that, to then organize the thoughts of how yttrium is important and the different parts of yttrium, such as the physical and the chemical properties. And then the instructor would slowly then become the classroom facilitator rather than the main lecturer of knowledge. You could also go about with this as project-based learning for the students to enhance the learning process and be more engaged and expand their research so they could research and have a project, create a presentation about how yttrium is so important. And then you could also go about this as with technology, as technology-based learning. They could create a PowerPoint presentation. They could create a Sway presentation, and then they could present that presentation through such as Microsoft Teams, through media such as that. You could also do this with cooperative learning groups. This could help students learn from each other through group discussions and student team learning. So some in-depth critical information that the instructor could first give about with direct instruction to introduce this topic to students would be going about and starting out with, first off, yttrium is never necessarily found as a pure element on Earth, but it is found in other ores and other rare earth elements, and that is how it is then extracted. The sources of yttrium and other rare earth elements include things such as the alkaline igneous complexes, carbonate-rich igneous rocks, and ion absorption clay. Next, yttrium actually exists in multiple oxidation states, such as the +1, the +2, and the +3, and is actually more stable in the +3 because that is where the element yttrium actually reaches noble gas conformation and configuration. Through actually the +3 phase, it reaches that of a noble gas and being that stable. And it actually forms binary compounds with other elements, such as phosphorus, carbon, selenium, silicon, and sulfur. Next, the element yttrium exists as a solid at room temperature in regards to its physical properties. It can exist for colors in a white, a silver, a gray, sometimes looks as a black with that solid room temperature. In regards to some chemical properties, it oxidizes on heating and air oxygen. It decomposes in cold water slowly and in boiling water rapidly. And again, the major applicable uses of yttrium include that it was used to create the first color television, specifically the red and the green light in the televisions. It can be used as a catalyst. It can be used to produce LEDs and lasers. It can be used to enhance those alloy properties and make stronger alloys. And specifically, it's used in cancer treatments from radioactive isotopes of yttrium. And the specific isotopes of yttrium in regards to cancer treatments is that they will actually attack specifically the cancer cells, not necessarily every cell, even the healthy cells. Next, the fate of yttrium in the environment could result in it catching fire spontaneously and exploding with excessive force. And even if you are attempting to put out a fire, yttrium would actually just start reigniting that fire again. In regards to toxicology effects, in humans, it could produce lung embolisms, lung cancers, and affect liver function in humans. And in regards to ecosystems, it could actually pollute an aquatic ecosystem, especially in seawater, if too much yttrium is built up. And for analyzing the element yttrium, we could also do that and go about that process with plasma mass spectrometry, where we can analyze yttrium and other rare earth elements in seawater, where sometimes it's very hard to analyze specific elements because of the high salt concentrations. Next, for the description of research and resources that are available to students in an AP chemistry class, first to go about with the technology-based learning resources, you can use Microsoft PowerPoint to then help them go about organizing their thoughts and creating their PowerPoint, or a SWAY presentation. SWAY is another way of presenting information. Or Microsoft Teams, if they were, for example, maybe wanting to present to another class at another facility, or even to other chemistry professors at another university, giving them opportunities such as that to present their research. Another resource that you could use is graphic organizers, such as concept maps. That specific graphic organizer would put the main concepts in the middle, and then the students could then organize their thoughts from there. Another resource could be scholarly article journals, scholarly sources, to then research yttrium and for potential project-based learning. These journal articles could provide students with specific examples of yttrium, and these examples of real-world scenarios that incorporate the element yttrium to help them understand that those elements on the periodic table, they can actually be utilized in our world. They're not necessarily one of those teeny tiny blocks that you just learn from a textbook. So the first example of a scholarly source that students could go about if they were interested in learning about yttrium is that yttrium ammonium carbonate could then be synthesized and prepared by reacting with hydrated yttrium oxide with ammonium carbonate. And that could actually happen in a chemistry lab if someone was interested in going along the lines of that, maybe interested in a career such as that. And then we could actually categorize and characterize the yttrium that is synthesized through different chemical analyses, such as the IR spectroscopy and things such as that, and calorimetry. Another example is that yttrium could actually be used to detect gamma radiation, and this can be utilized in the detection of environmental stability. So students could also go about learning in the areas of that. If they were interested in the areas of nuclear chemistry, they could look up different resources to help them understand that yttrium can actually be applied to a real life situation and real world scenarios. And out of my sources, there are 5 here listed for this first slide. And then I have another 5 resources on this slide, resulting in 10 sources that I used altogether. Thank you very much for listening to my presentation. I greatly appreciate it.